This video is going to show you how to apply Kirchoff's first and second rule to a simple example problem. In the little circuit I have a loop on the left, and I have two junctions, one at the top, one at the bottom, and I have the circuit on the right, and that's not shown because I'm not going to need it for what I'm going to show. I've got these currents, I1, I2, and I3, and I've assumed some directions by the arrows. And assumed is correct. I haven't put any more thought than flip a coin and pick these directions for all that matters. If I've chosen a direction wrong, when I do my math and I find the number for I1, I2, and I3, it'll come out negative. So if I2 is going the wrong direction, I'll get a negative I2 as my answer. And that'll tell me in retrospect that I need to flip I2 in order to figure out the direction through that 10 ohm resistor. First thing I'm going to do is the first rule. It says the sum of the currents going into the junction equals the sum of the currents going out of the junction. So I1 and I2 go into the junction, and I3 comes out. So I write the first rule as I1 plus I2 equals I3. So my goal here is to find the currents, I1, I2, and I3 in this problem. That means I have three unknowns, so I'm going to need three equations. I've got the first equation up there with the junction rule. That was easy. From the junction rule, we'll go to the loop rule. So for the loop rule, I'm going to ignore the right-hand side of the circuit and just focus on the left-hand side. And there's the current I1, because the 9-volt battery, the 5 ohm resistor, and the 6-volt battery, they're all in series, so they all have the current amount of I1 going through them. Now, I'm going to look at my batteries, identify positive and negative signs on my battery, and I'm all ready to start analyzing, so I know where the high and the low energies are now. I'm going to pick my direction of analysis. That's my blue loop here, and it's going to go in a clockwise direction. I could have chosen going counterclockwise. I picked clockwise as a random choice. And I'm going to start where the star is. So I'm going to start up here in the top right-hand corner and go around my circuit from left to right across each element that's in the circuit. So the first thing I'm going to look at for loop rules, remember that everything is equal to 0. So 0 equals all the changes in energy of these four components. As I go from left to right from the star, I go from the star to the negative side of the battery, then to the positive side. The negative side is the lower energy, the positive side is the higher energy. So to go from low to high, I have to add voltage. So for the battery, that's easy. I just add 6 volts. So that's the start of my loop. Now I continue past the positive side of the battery to the junction and then down to the 10 ohm resistor. And through the 10 ohm resistor is the current I2. Now current comes from high energy to low energy by our definition of the flow of current. So I have high energy at the top, low energy at the bottom. As I move in this counterclockwise direction, I encounter the high energy side first, then low energy. That means I'm going to lose energy. Well, to figure out the loss in voltage, I've got to use Ohm's law. In fact, I don't have the voltage, so I've got to use I times R. That is I2 times 10. So to lose energy, to go from high to low, it's going to be minus. It's going to be the current times the resistor, 10 ohms. So I go past the 10 ohm resistor and then to the 9-volt battery. Now when I go to the 9-volt battery, it's got a positive side of the high energy and then low energy. So as I go from plus to minus, because I'm going counterclockwise, I'm going clockwise in my analysis direction, I go from high energy to low energy. To go from high to low means I have to remove voltage. So that's going to be minus 9 volts. Continuing around my circuit and getting up to the next 5 ohm resistor, as I get to the 5 ohm resistor, I look at the direction of the current through the 5 ohm resistor. When I look at that, the high energy is where the current came from, that's the top of the resistor, and the low energy is the bottom. So as I move in a clockwise direction from bottom to top, I encounter the low energy first to the high energy. To go from low to high means I have to add energy to get up to the high energy. So that's going to be a positive I times R. And the I is going to be the current going through that resistor, which is the 1, or I1 times 5 ohms. So that's my loop equation. Now I have 2 equations and 3 unknowns. To find the third equation, what I would do is look at the other half of the circuit and make a second loop, and I could figure that out. If I had to find the power for anything, I know that once I find these different I's, I could then use the power for the batteries using P equals IV, or the power through the resistors using P equals I squared R.